Hello world, and welcome to Web Dev Frontiers. My name is Tamas, and I'm here to share my experience with you in web technologies. And in today's video, we're going to take a look at how to use OpenAI SDKs with Langchain's SDK to consume a PDF document and then have a prompt that will allow us to ask questions about the loaded document. So if you're ready to see this amazing use case using AI, let's jump straight in. All right, so before we actually get down to writing some code, there are a couple of things that I would like to explain to you. First and foremost, this is the most important thing, you need to register for an OpenAI SDK key. Now, in a previous video where I talked about OpenAI SDK keys as well, or OpenAI SDKs in general, I'm going to link to that. I already told this to you, but I'm just going to reiterate this right now in this video as well. So essentially, even though you could have an ChatGPT account with OpenAI, in order for you to be able to register for an SDK API key, you need to be registered separately on platform.openai.com. So please visit that website, create an account, and then once you do that, you can click on API keys on the left-hand side, and then that will allow you to create a so-called project API key, which is, what they now call the API key. And make sure that you record that somewhere because you will need to use that. You can actually create an .env file for your Node.js project immediately, and then just create a key in there called OpenAI_API_key and just paste the key in that you just copied. So OpenAI is going to be one thing that we're going to be using. The second thing that we're going to be using is going to be called Langchain. So what is Langchain? The way I like to think of Langchain is this super framework that allows you to create robust AI applications by using different LLMs, applying different configurations, and it allows you to do a large number of things. Now, in this particular video, we're going to be using its feature, which is called a document loader. Now, if you look at the Langchain documentation. By the way, langchain.com is the website that you're looking for. So inside the documentation, you will find a section that is called document loaders. Document loaders allow you to load contents of your various documents into an embedding and as such into a vector database, but more on that later. And as you can see, they have two types of document loaders. They have file loaders. So basically you can take a CSV file and consume content from it, JSON files, PDF files, which is what we're going to be using, text files, unstructured. Furthermore, web loaders allow you to load data from things like a Couchbase database, for example, Figma, Gitbook, GitHub, PDF files, again, S3 files, and YouTube transcripts. So imagine a scenario where you have a YouTube video, you pass it to the YouTube transcript web loader that is going to be embedded, stored in a vector database, and now you can ask questions about the content of the YouTube video, and the LLM should be able to answer your questions based on the content of the YouTube video. I think this is a really, really amazing use case. But for our use case, we're just going to stick to PDF files. In fact, let me show you the PDF file that we are going to be loading, which is the Apple Watch user guide. So this user guide is available on Apple's website. It's 292 pages in length. And as it says here, it will teach you everything you need to know about the Apple Watch. And it tells you how to set up your Apple Watch, how to configure it, how to change settings. So, all sorts of information. Is like a full-blown user manual. So we're going to consume this, and then we're going to have a conversation with the LLM, and we're going to ask questions about the Apple Watch in general, and it should be able to answer our questions based on this document. Okay? So this particular feature is called document summarization, and then you can, of course, create a document summarization application, not just consuming PDF files, but you can, have PDF files, YouTube videos. So you can have almost like this big Q&A knowledge base based on your data, and then you can just feed that into an LLM, have a discussion with an LLM, and it should be able to provide you with relevant information based on the content that it consumed. Okay, so make sure you have the OpenAI SDK key. Make sure that you familiarize yourself with Langchain. Grab a PDF document. You can use this Apple Watch user guide as well. And if you have everything, then let's go ahead and write some code as well. So I've already set up my .env file with the OpenAI SDK key. The next thing is that I'm going to add a couple of import statements to my app.js file. And the 5 things that we're going to be importing are, of course, OpenAI itself. Then we're going to import these 2 things called the memory vector store and OpenAI embeddings. Now, before we progress further, let me just give you a very brief overview of what a vector database is and what an embedding is. And if you're interested in this, I can do a more detailed and in-depth video about it, but please let me know in the comment section below. But essentially, there are vector databases. A vector database is nothing more than just a normal database, except the way it stores the data is in a numerical format. So think of a data represented as a very large array of numbers, normally, multi-dimensional arrays as well. And so essentially the memory vector store is just going to pretend to be a vector database, but it's going to store all these so-called embeddings, which I'll tell you what they are in a moment. So they're going to store these embeddings in memory. Now, there are, of course, full-blown vector databases out there. I think Weaviate, Pinecone, R2 are the ones that are used quite a lot. But in this case, for this example, we're just going to use Langchain's memory vector store. Now, the third import is the OpenAI embeddings, which begs for the question, what is an embedding? So the way I would like you to think about an embedding is basically transforming the data into numerical values. And then these are the numerical values which then subsequently get loaded to the vector database. So let me give you a very simple example. So for example, let's say you have an apple. Okay, you could represent that apple based on various properties and qualities it has, right? So you could say, how red the apple is, or how green the apple is, what, size the apple is, what kind of taste it has, whether it's, sweet, sour, etc., etc. And so all this data would be represented as numbers. Then you have more fruits, bananas, pineapples, peaches, whatever. And those would be represented as numbers as well. You load all these numbers, these embeddings, into a vector database, and now you can run similarity searches or other type searches based on the numerical representation of the data. Now, why this matters is because essentially if I just look at the sweetness of the fruit, that is now going to be represented as similar set of numbers. So if I'm asking for, fruits that are sweet, maybe based on the closeness of the numbers to each other, we would get back, apple and the peach, for example. And basically the process of embedding something means that you're going to represent it as numbers, and then you take those numbers, and then you're going to load them into your vector database. Now, the other 2 things that we're doing here, character text splitter and PDF loader, I think those are very straightforward. We're going to be, working with a PDF, so we need to load it, and we need to find a way to split the text inside the PDF itself so that we can apply embeddings to it, so that we can store it inside the memory vector database. Okay, so let's see what we need to do next. Okay, so now since this is going to be a Node.js command line application, I just use process.argv to grab a question. So that's going to be the 3rd argument. So I use array destructuring to grab the question. So what we will try to do is, load the Apple Watch guide and then just ask questions about it, and we should get an answer. So I need to make sure that I store the question somewhere. Then I create a new instance of OpenAI and I pass the API key to it. After that, I have this methods called create store, which basically is going to accept a document, and then it's going to call the from documents method from the memory vector store, which is going to take a document, like a PDF document in our case, and is going to create a new AI embedding from it. Okay, so this is going to create the embedded version, or it's going to store the embedded version of the PDF inside the vector database. The next method that I have here is going to be the one responsible for actually loading the data from the PDF. So I accept a file name. So I'm just going to put watch, and then that's going to be replaced with watch.pdf in this case. Of course, you can change the path, depending on where the documents are that you want to use. And then I'm just going to call loader.load. Now, just to let you know, you can actually specify a more sort of granular way of splitting the document, loading and splitting the document. So as opposed to just calling loader.load, I can call loader.load and split, and I can call the new character splitter, and I can, specify the chunk sizes, chunks, overlap, and separators, right? So I want to make sure that the text inside my PDF is going to be split by the new line character. That allows us to process the PDF slightly better, as opposed to just calling loader.load, just say load the whole thing. This is going to be a little bit more sort of precise. Okay, so we have create store, docs from PDF. Let's see what's next. And of course, now we just need to load the actual store. So we're going to have this document called Apple Watch, which is going to be read by this function that we just specified called docs from PDF. And then we're going to then create the store. So load store is essentially going to be responsible for creating the in-memory vector database based on the embeddings that we have just created. Okay, so that is called load store. And now comes the largest section of the code, which is going to be called query, or at least I called it query. So it's an asynchronous function. First, we're going to load the store, and then we're going to execute a similarity search where we pass the question as the first argument. Okay, so similarity search is a method, as you can see, that is exposed from the store itself. So similarity search will allow us to query our knowledge base, our document, our embedded PDF document based on the question. Okay, so it's going to find the closest answer to our question based on the data that it has. And of course, we need to have this in a sort of conversational setting. So we're going to use OpenAI's chat completion method, or rather the create method from that, specify one of the GPT models. It doesn't have to be the Turbo 16K. It can be, any other model. It's very important that we set the temperature to be 0 because I do not want the model to hallucinate. So again, temperature can go from 0 to 2. 0 value means no hallucination. The large language model will not make stuff up. If you put it to 2, it may invent things that it believes it would be correct, but it may not be. It's just going to be a lot more, how should I say it, a lot more creative. And then we have two messages. One is a system message. So this is where we set up, or we tell the LLM how it should behave. So we tell it that this is, you're an assistant. Your task is to learn the documents that get sent to you. So in this case, it's going to be watch.pdf. And I'm going to ask questions. And then I specify the document is going to be about the Apple Watch and watchOS itself. And then I have a user input. So this is, again, if you use ChatGPT or any other interface, this is what you would put in, right? So every time when you see role user, that's you typing something or asking something from the large language model. And so our input here is respond to the question below using the given context. And of course, the context is you're the assistant and you're, you know stuff about the Apple Watch because I just gave you a document about the Apple Watch. And if, we also tell it that, hey, you should not fabricate information. You should not come up with stuff that you don't know. Just stick to the facts based on the document. And then just print out the question. And then we're going to get a result, and then just iterate through the result. And that's going to be essentially the response coming back from the LLM. Okay. And then I also print out sources, which basically says, hey, the information came back from, watch.pdf. Now, this is useful. And the reason why I have this here is because if you have multiple sources, YouTube videos, multiple PDF files, then you may want to know what document was used to provide you with an answer. Okay, so I then also have query. So let's save this file and run our application and see what happens. And just before I forget, and before you run this, you need to make sure that you install the right dependencies as well. So I'm just going to install the appropriate dependencies using the npm-i command. And those are Langchain, @Langchain/OpenAI, and then PDF parse, like so. All right, and once the installation is complete, we can run our application by specifying the location of the env file. And then our very first question is going to be, I lost my watch, what should I do? So let's see if we can get an answer using our app. All right, so here we have it. We have the context. The provided context is about finding a lost Apple Watch using the Find My app and using the focus feature on the Apple Watch to reduce distractions. And here's the response. It basically says, if you've lost your Apple Watch, you can use the Find My app on your iPhone to locate it. And it tells you how to do that. And notice we also have the source, which is watch.pdf. So it actually was able to give us a very precise answer. Now, actually, one thing that I would like you to do is open up the PDF file, and you will not find these exact sentences in the PDF file because this was generated based on the content of the PDF file. And this is not an exact sort of copy paste type of thing where the LLM just copied the paragraphs and then pasted it. It actually formulated real conversational sentences, and that's what it gave back as an answer based on the question that we asked. Let's just for fun ask it another question, which is, how do I charge my watch? And now we get a step-by-step guide on how to exactly charge our watch. It tells us, it should be a ventilated area, it should have a USB-C cable, etc., etc., etc. So this is really, really amazing. Okay, and then the last example that we're going to ask it is going to be something that it shouldn't be able to answer. And the question is, how long does it take to reach a full charge? And we don't have a specific information, and that's what we get back, right? Because this is a very generic question, like, to reach a full charge of the Apple Watch, depends on what the battery percentage right now is, etc., etc. So because we said zero hallucination, always, try to use the entire document to answer the question. It says, well, I'm sorry, I don't really know because the document doesn't exactly specify anything related to this. So there you have it. Now you have this wonderful document summarization app where you can load multiple PDF files. I also highly encourage you to try this with the YouTube transcript and some other options like CSV files. Maybe you have some data at your company that you want to analyze, or you need to analyze, and now you can get the LLM to actually analyze it for you, and you can ask, maybe your boss asked you a question and you can now ask the same question from the LLM, and it should be able to give you a very precise answer. And that's it for this video. I hope you enjoyed this. I hope you learned a couple of things about AI and the ecosystem that is clearly booming these days. If you have some very interesting use cases, maybe using Langchain or other types of embeddings, please let me know in the comment section below. Otherwise, if you like this video, I would appreciate a thumbs up. And of course, please subscribe for more such content in the future. Thank you for watching, and I'll see you in the next one.